So I'll tell you what. Next time I hit you, if you don't move your leg, I'm going to give you an A in the class no matter what you're You get an A in the class if you don't move your leg. They're like, okay, Dr. Brown, I'm ready. And I hit him on the knee, and out that leg would come. And they're like, oh, darn it, or something more severe. So I can absolutely tell you with confidence that as long as it's being performed correctly and the person is healthy and their nervous system is healthy, they will not be able to override it voluntarily. Even if you tense up. Now, putting your foot on the floor so it can't kick, or bracing it against the back of what you're sitting on will interfere with this. But as long as you've got them in the right position and you hit them on the right spot, they can't stop it. It's involuntary. It's hardwired into your nervous system. I'll give you an A. Just don't move your leg. Oh. All right. Let's try another one. You guys are having some fun with this. Let's try another one. This is another example of a spinal reflex. Question? Okay. This is something called the withdrawal reflex. So can I use you as my example here? All right. Well, well, the picture I have is of a man. So I'm down to two guys. If you don't want to do it, Cody, right? Maybe Cody will. Cody, do you want to be our guinea pig here? All right, because Dave does obviously is not excited about it.
I'm so uncomfortable.
All right. Because here you are half naked, right? All right.
Yeah, he's a ghost.
All right, so Cody went to the beach over the weekend. The weather's starting to warm up. There was a nice sunny day. He said, I don't care if there's thunderstorms coming. I'm going to the beach. And so he's walking along the beach, in the surf, along the tidal area, and it's a public beach, and the bikers are all coming into town. And sure enough, under the water where he couldn't see it, there's a broken beer bottle. And he steps right down on it, and he lacerates the bottom of his foot. All right. So the sensory receptor for this reflex are the pain receptors. He has damaged the bottom of his foot. So action potentials from his foot, sensory action potentials, come streaming up his sensory neurons, through his nerves, through the dorsal root, past the dorsal root ganglion, and into the dorsal side of the spinal cord. Now, this is what's called a polysynaptic reflex. Because it is going to have an interneuron. So the sensory neuron will synapse onto an interneuron. That interneuron then forms several branches. So the first branch of the interneuron forms an excitatory synapse. Okay, I got that one. Forms an excitatory synapse with the motor neurons that control the hamstring muscles on his injured leg. So action potentials run down the motor neurons to the hamstrings, and the hamstrings contract. That's going to flex his lower leg at the knee. And since he's standing up, the effect of that is to raise his injured foot up off of the broken glass. He withdraws his injured foot off of the painful stimulus. Hence the name withdrawal reflex. It works the same way in your arms, absolutely. All right. Now, this is also what's called an Imp the Lateral Response, because it occurs on the same side of the body as the stimulus. If Cody stepped on the broken glass with his right foot, it's his right leg that he pulls up. Now, we're also going to get a branch off of this interneuron, a second branch, that is going to form an inhibitory synapse. To the motor neurons for the quadriceps. Same sort of process that we saw with the knee-jerk reflex, only in opposition. So if he's contracting his hamstrings, we need his quadriceps to relax. So the hamstrings are going to take control and move his leg without getting any lip from the quadriceps. No back chat, shut up, I'm in control right for this second. So the quadriceps relax, the hamstrings contract, he flexes his lower leg at the knee and pulls his foot up off of the broken glass. It's the lateral response. Oh, but there's more. Right? You'll notice that there's a third branch to this interneuron that crosses over from the right side of the spinal cord to the left side of the spinal cord. Crosses over to the other side. And here we're going to get two more synapses. So if it was his right leg that stepped on the glass and his right leg that's lifted, his left leg is going to have the quadriceps excited, so they will contract. And we're going to get a synapse on his opposite leg hamstrings that is inhibitory, so they will relax. Now, Cody, like all good human beings, has only two legs. If he is lifting up his right foot because it hurts, all of his weight now has to shift over to his left leg. His balance has to be readjusted so that all of that weight and all of that pressure is being supported by his left leg. And that means it has to be braced to take that shift in weight. We have to keep this leg extended. So, on the other side of the body, the quadriceps are contracted and the hamstrings are relaxed, so he's got that leg braced out straight. This is called the contralateral response. It's a contralateral response if the side of the body that's responding is on the other side from where the stimulus occurred. He stepped on the beer bottle with his right foot. His left leg is braced to take the shift in weight and pressure. That's the contralateral response. So this withdrawal reflex is quite a bit more complicated than the knee-jerk reflex, because you have both ipsilateral and contralateral actions. Complicated, but I think you guys can once you've had a chance to look through it again and kind of work your way back through it step by step, I think you'll be able to get this not too trouble. All right, and as you pointed out, we have the same reflex in our forearms. It's a little bit more workable when you're talking about quadruped animals. So if your dog or your cat steps on something that's painful or unexpectedly hot or unexpectedly cold, they'll pull up their paw and brace their weight with the opposite front leg. Since humans are bipeds, it's a little bit less productive. If you reach out and touch something with your, say, your right hand and it's too hot, you will reflexively withdraw that hand. If you're looking very carefully, you may see the other hand shoot out. Maybe not fully, but we do still have that wiring there, pulling back one arm as if you needed it to keep your balance, which you probably really don't. But as if you needed to keep your balance, the other arm will extend or partially extend. Now, both of these examples are what are called somatic reflexes. In which the effectors are skeletal muscle. Typically, we think of skeletal muscle as being under voluntary control, but when one of these reflexes gets activated, your conscious mind is not going to be able to do much until the reflex is over. You are going to kick out your lower leg. You are going to pull back from the broken glass. We also have a number of what are called visceral reflexes. In which the effectors are smooth muscle or cardiac muscle or glands. Things that are usually under involuntary autonomic control. These reflexes, for example, will adjust your blood flow and blood pressure when you go from a sitting position and fairly relaxed to standing and walking away. Blood flow has to be shifted around so that your brain doesn't run out of oxygen. You got to get a little bit more blood going through the muscles, maybe take some away from your digestive organs. Things get moved around, but you're not aware of this happening, and you kind of rely on them to happen. If they stop happening, people stand up and they faint from lack of blood to the brain. It's kind of exciting. Called orthostatic hypertension. You know that. You'll notice this as you get older. The reflexes tend to slow down as people age, and so people who've been lying down or sitting down for a long period of time will stand up kind of suddenly, and they're like, woo, head rush, because the whole room kind of goes, woo, spins around. Their blood pressure hasn't adjusted, their blood flow hasn't adjusted quickly enough. So, kind of fun. All right. Let's see.
So the tide reflex would be one of these? You know, like when you get water on your face,
Yes.
it's supposed to slow your heart rate?
Yes, that would be an example of a visceral reflex. And let's just finish this up real quick. As I mentioned when I was talking about the knee-jerk reflex, almost everybody's probably had that one tested. Reflex testing is used as a diagnostic for changes to the nervous system. So, for example, if the reflex action becomes exaggerated, and remember how to spell exaggerated, or distorted, or suppressed, or delayed, bless you, or entirely absent, that could be an indication of abnormalities, lesions, damage, trauma to the nervous system. I'm sure you guys watch the medical shows where someone comes into the ER and they're shining a little light in their eyes, right? What they're checking for is the pupillary reflex. Someone shines the light in your eye, your pupil's supposed to constrict. But if you've had a stroke or severe head trauma, if you're developing a subdural hematoma, that reflex may not be there, or it may be suppressed or delayed. And so just by shining a light in somebody's eyes, like, oh, brain injury, we've got to get this guy into x-ray, start a CAT scan, book the MRI. So this is why they're doing it, to make sure that your reflexes were working okay. Whack you on the knee with a little rubber hand. Yep, your leg kicked out, good to go.
I must have scared some doctors. I just remember it only working once, and the rest of my time, no, nothing. I've always wondered, if they didn't see anything, what they were looking for, but maybe I was just
You're a little too young to be part of the polio epidemic. In fact, you're a lot too young to be part of the polio epidemic. But this used to be one of the big concerns when people's reflexes weren't working, is because they were the neural damage due to a polio infection. But of course now everybody gets vaccinated, so nobody gets polio in this country.
One of my other teachers here at the school was a polio survivor from back during the polio epidemic. He spent time in the iron lung.
I've watched videos of what was going on during the heydays of the polio epidemic, and I got to tell you, it is deeply distressing. Because while it does occasionally hit adults, most of the victims were young children.
He said he was a young child when it happened, but he's told us multiple times he trips a lot when he walks because he's lost all the sensation in the leg. And one of the things he did let us see was that his one leg is it looks pretty big, like there's no muscle around the bone anymore, where the one leg is kind of bigger.
Yes, muscle atrophy is also a definite consequence of polio. Yeah.
Is that FDR? Right?
Yes, that's the guy. That's the guy. All right, so wow, we got through that really, really fast. I'm so happy. As far as I'm concerned, that's the end of the new material. All right. So we're going to take a break, and if you want to do some review, come back in about 10 minutes, and I'll answer any questions that you have. We'll repeat.